In this chapter, we're going to learn how to configure and wire up a battery bank, and then how to make a battery box to put the batteries and equipment in. Let's dive right into the electronic theory first, and then we'll show you how it works out in the real world. Batteries add up the same as a photovoltaic panel. They used to call photovoltaic panels batteries when they first made them. So, when you memorize this, it works for both panels and batteries. The first thing to know is that when you wire batteries, or panels, in this case batteries, in series, the voltage adds up and the current remains the same. So on the diagram on the left, you can see if you have two, say, trolling batteries, 12-volt batteries at 100 amp hours, and you wire one's negative to the other's positive, and then take the plus off the one on the left and the minus on the one on the right as your output, that voltage adds up to 24 volts, but the 100 amp hours of each battery remains the same. So now you have 24 volts at 100 amp hours. If you parallel them, as in the diagram on right, that means that both negatives go together and both positives go together as the output. Well, then the voltage remains the same, but the current capacity adds up. So if you have 200 amp hour batteries, now you have 12 volts at 200 amp hours. You have to memorize this concept. Series, the voltage adds up, the current remains the same. In parallel, the voltage remains the same and the current adds up. So get that well into your mind because you're going to use it when we get to the panels as well. Here are three examples of how we might wire a typical deep cycle trolling battery in three different configurations. These are 12-volt, 100 amp hour deep cycle batteries. On the first example on the left, we're just putting two of them in series, like I previously described, negative to positive on both of them, and then one of them's negative output and the other's positive output. That gives us 24 volts at 100 amp hours. It adds up the voltage. In the middle example, we are paralleling them, like I showed previously, with a positive to positive and negative to negative, and those two lines coming out gives us the original 12 volts, but doubles the amp hour capacity of that bank. Now in the last example, we have four batteries in series, and we're adding them up just like we did in the first, where we're going negative to positive, making a circular loop around, as you can see, negative to positive, negative to positive, negative to positive on the right, and then taking the top two plus and minuses out. That gives us 48 volts at 100 amp hours, adding up that voltage, but leaving the current exactly the same. If we simply change those to 6-volt batteries, in the example on the left, two of them in series now add up to 12 volts because we're adding the two 6s to 12 volts, and it's still 100 amp hours. In series, the current remains the same. In the parallel example, where the current adds up, we still have only 6 volts because we're paralleling them, but now we have 200 amp hours of capacity. In the 4 in series example, now we have 24 volts, adding up all the voltage, 6 times 4, but we still have the 100 amp hour capacity. Realize that in that bank of 4, we could make several banks of 4 like this and then parallel those banks to bring up the current capacity and keep it at 24 volts. In this example, I knew I needed a 24-volt battery bank, but I also wanted about 300 amp hours. So first I took 4 of them and put them in series to get my 24 volts. But I'm still at 100 amp hours because that's the rating of each battery. Then I paralleled 3 sets of 4 of these, as you can see on top, plus to plus and minus to minus, to add their amp hour capacity up. So each bank of 4 is 24 volts at 100 amp hours, but added together in parallel, the output is still 24 volts, but now at 300 amp hours. So you can see how, once you know if you were going to have a 12 volt or 24 volt or 48 volt battery bank, and you need a certain amount of amp hour capacity because of your panel output times 25, that you can combine a combination of series and parallel batteries to arrive at your appropriate voltage and your desired amp hour capacity total. Now let's take a look at how these batteries are wired. This is a 24 volt system using 6 volt batteries. I've made banks of 4 batteries, in other words, putting 4 batteries into one bank to make a 24 volt system. Now this is a 6 volt battery, it has negative and positive, and I've jumpered the positive to the negative on the next battery. And notice that I've also put a little bit of red tape on the end of that jumper to remind me which goes where. So this first battery is in series with the second battery, which is in series with the third, positive to negative, and in series with the fourth, adding up all of their voltages And that would mean that this is now a 24-volt bank, these 4 batteries right here. And their connection point then is the end. And what we're doing is, out of 24 batteries, we're making 6 packs of 4. Each 4 is wired exactly the same, like this first 4. And then the positives and negatives are jumped together at the end. So there's negative to negative to negative on each pack of 4, and our positive to positive. I had a little bit of red wire, so I used red 2 gauge in there. You can use 4 gauge or 2 gauge there. And go ahead and strap them together. So we are paralleling all of these banks of 4 packs, 24-volt pack of batteries, into 6 parallel banks of 4 each. Each bank of 4 series wired to make 24 volts, and then paralleled. I'm going to finish wiring the parallel jumpers. Paralleled each bank of 4 so that we add up the current. When you series them, the voltage adds up. When you parallel them, the current capacity, the amp hours of the battery, add up. So we're getting a 24-volt system here at 1800 amp hours once all of these batteries are paralleled.
So let's restate this clearly. You're going to add up a set of your batteries in series to get your desired battery bank voltage. Say if you were going for 12 volts and you had 6-volt batteries, you'd put 2 of them in series to get 12 volts. Or a 24-volt system and you had, say, 12-volt batteries, you might put 2 of those in series to get to a 24-volt point. Then parallel connect clones of that original set to get your desired total amp hour capacity. Because series adds up the voltage when you put them in a row, and parallel adds up the current in amp hours. And I always do suggest 24 volts is a pretty good battery voltage to work with. What I'm going to say next is very important, and you need to memorize this. Once you pick 12, 24, or 48 volts for your battery bank voltage, you need to be able to figure out how much amp hour capacity you need in your entire battery bank. Well, you do this by multiplying the maximum current output of the photovoltaic array in amps by 20 to 25 times to get the amp hour capacity you're going to need in that battery bank. And this is going to cover you for several days without sun as your energy storage. Go 25 if you have more rainy days in your area, 20 if you've got a lot of sun. And for healthy batteries, you have to match the battery bank size to the array's output. Now this is important, how to calculate this correctly. You will wire your panels at a higher voltage than the batteries, and the charge controller will convert that higher voltage down to your battery voltage, your battery bank voltage, while increasing the current. So to calculate your battery bank capacity needs correctly, take the total panel array output in watts, add up all the wattage of each of your panels, and divide by your battery bank voltage. Then multiply by 20 to 25. Say 2,000 watts divided by 24-volt batteries equals 83.33 amps. And 83.33 amps times 25 is 2,083.3 amp hours. That's what your battery bank capacity needs to be. Now the higher the multiplier, the more you're going to spend on your battery bank. So what are the battery multiplier considerations here? Well, if you have more rainy days, you're in a rainier area, you need to go more towards 25 times on the battery size. But if you're in a very sunny area and you have mostly sunny days, you can go down towards a lower number like 20 times. Or if you're going portable, you could even go quite a bit lower than that. So 25 times on the battery multiplier gives you about 4 to 5 days of backup power, roughly. 20 times, about 2 to 3 days backup power. And 15, 1 to 2 days of backup power. Now here's how to select the batteries. Find an industrial battery distributor as close to your location as possible to reduce the transportation costs and distances. In other words, if they have to be shipped, or maybe you can go pick them up. That would be best to save money. 2, look at the deep cycle batteries that they have that are over 100 amp hours in capacity. You don't want to work with anything smaller than 100 amp hours. Now find the best value by designing your battery bank using a few different models that are available from that distributor. In the 6-volt or 12-volt, see what they have and configure it up. You can even do it on site when you're there with a piece of paper and pencil. And then calculate the cost to make your battery bank and pick the battery that offers the best value and quality. But remember that using a higher voltage or higher amp hour capacity results in having to use fewer batteries, and this results in needing fewer jumpers and battery terminal lugs, which saves you time and money making them and buying them. And of course, if you're using less of them, use a larger wire gauge as well. These are the things to consider when you go out and buy your batteries.
I want to talk to you about safety when you're working on your batteries and hooking up your jumpers. there's a few things you have to remember, and that is that all of your tools need to have tape on the handles. Tape all of the handles up all the way up to the top. See the screwdriver too? Also taped all the way up. The reason for that is if I drop these into the battery compartment, I do not want to short, and this is long enough to short the positive to the negative terminal on this battery. A very nasty explosion may occur if you do this. So tape all of your tools up first. The other thing is you must wear safety glasses, and you can keep those handy around your batteries even when you're just filling them up. So safety glasses are a must, and no jewelry. Now I have a nylon banded watch over here. Could get away with that, but I would suggest absolutely no jewelry. Now I'm not working on the batteries right now. But no jewelry, tape the handles of your tools up, safety glasses, and never store or lay your tools into the compartment while you're working on it. As you're wiring it up, keep the tools, all tools, out of the battery compartment. Never store them there while you're just taking a break to do something or going to move something over. Keep all of the tools singly, take each tool in, tighten the job, do the job, put the jumper on, take it out. And those are the rules you have to really make sure of when you're working on putting the jumpers in on your batteries.
Let's review some of our safety concerns here. We do not want to make a short circuit. You've heard of this, and this is what makes catastrophic discharge of current happen. We want to avoid this, and that is never to make a circular route connecting the plus and minus of any battery or battery bank outputs together. That means the plus and minus of a single battery cannot be connected together, or of two batteries in series. The outputs, plus and minus, can never be connected together. We're also looking at two of them in parallel. See where the outputs are, plus and minus paralleled, and then to the outputs, those two cannot be connected together. And if you're using a battery bank of 4 in series to provide your, say, 24 volt output or 48 volt output, those outputs, plus and minus, can never be shorted together. So that's what you have to remember. You're avoiding that with your taped up tools, and you're avoiding that when you're wiring this up to the charge controller.
Now I've determined the size that I wanted to use between these two posts. I'm going positive to negative because I'm putting these in series. I cut that exactly the length I wanted, which I know I'm going to have to reduplicate. And then I know I'm going to be jumping between these two terminals to make my 4-pack. And so I need to make a little jumper that I'm going to put sort of vertical. Let's take a look over here. And I'm going to go ahead and have the loop come up sort of vertically like this to stay out of the way of the batteries caps so we can fill pretty easily. So I'm going to cut the shortest amount that I can make a little vertical jumper, and that'll be the exact amount I need. So I'd say, okay, make it, don't make it too short, and then you'll know that you're going to use that amount, and you can duplicate that as many times as you need to go ahead and make your banks of batteries. So pre-measure it, mark it, and then you can count how many you're going to need for the jumpers. In this case, we're putting 4 in series because they're 6 volt. If you had a 24 volt system and you're using 12 volt batteries, you might put 2 in series. So you just need 1 jumper here. But we'll show you more about battery configuration. But you need to figure out the lengths of the jumpers you need and then cut the pieces. And I'd say 4-gauge wire. 4 is what I suggest, and then put your lugs on, and then we're going to put them onto the batteries here. When we do this, I will then coat the terminals in a spray. You can get the little red and green discs that go over the posts that keep corrosion from happening, or you can use a battery terminal spray, which you just put over the top, and it coats it from being able to oxidize and get that crust that battery terminals get on them. Or there's a third old trick method where you take a couple of very shiny copper pennies and just lay them on top of the terminal over here, and they pull away the corrosion to the pennies and replace the pennies about every 4 or 5 months. Take a look at them. If they get corroded, take them off, wipe it off, and put some fresh pennies there. A good use for your old pennies. Let's take a look at how to put lugs on wire. This wire here is rather large. We're going to use this for a demo. Some of your stuff may be a little bit smaller than this if you're going to be jumping between the batteries. This might be a bigger size to go to your inverter from your batteries. Here's a rather large aluminum lug with a screw head on it. This is the one we're going to give the demo on, but the smaller wires will have the same type of connection and just a smaller lug on the end over here. So this is the screw type of aluminum one. I like to use these, and we're just going to unscrew it there. Here's our little box cutter, cutting off about 1/2 inch on this. Don't cut off any more than you need because the insulation is there to protect you from, having the wire exposed. That's what you want. Now we're going to put it into the lug and be sure that it doesn't go past the end of the lug over here into the area where the nut and bolt are going to be coming off, say, the battery. You don't want it to protrude, it could get in the way. I'm going to put it right there. And when we're putting on the first one, it doesn't matter the orientation whatsoever. Be sure that your screwdriver is a big blade that fits the little screw head here perfectly, because you don't want to strip this thing. Now, what I will do, and I'm not going to do here because I'm actually not making a jumper, is I would put a little bit of thread locker on here. Loctite is one of the brands. Several companies make it. And that will keep this thing from unscrewing on you later, because they tend to want to unscrew. So when you sit you down, remember that you're working aluminum against aluminum over here with this threaded screw, and you don't want to strip it out, so you got to be really careful not to turn too tightly. You can feel it when it crushes the wire just right. And take it a little bit more than that. You got the locker on there, the thread locker, so you're good. So there you go, nice clean connection, and that way you can make up all of your jumpers first and have them all ready to rock and roll. Now also, know that the hole on your lug may not be the right size, it may be a little bit small to fit onto whatever you're putting it onto. So check beforehand and be sure that it slips on, and if it does not, go ahead and put this into a vise and take a drill and drill it out for the exact right size. You don't want to make it really too much bigger than it needs to go on to fit on perfectly. So there you go, get all your jumpers made beforehand and be ready to go. There's our cables coming together.
Now I'm wiring my banks in parallel at the rear, and notice that when I put them on the post, I'm putting them back to back so they have good clearance. And then when I lock down the nut, I put a little bit of Loctite on there, thread locker, slowly and deliberately.
Now notice when I put this jumper in here, I had to get away from the cap. I just bent the jumper out of the way. I pre-measured these, and I knew exactly how many jumpers of each length I needed, so I pre-measured, counted them, wrote it down, and then went and cut them all and got all the jumpers ready first.
Something to remember is that battery jumper wire size is determined by the size of your inverter, and larger is always better. For inverters under about 2,000 watts, you may use 4 or better 2-gauge wire and the matching lugs. For 2,000 to 4,000, you should use double-aught wire. Always choose the larger size wire if you can afford it.
Now this is how we put the battery box together. You can either pour a foundation underneath using 2x6s or 2x4s and pour a slab basically on top of level ground, and then just go ahead and back pour it like you would make a slab for anything else, or an air conditioning slab or anything else. But here I've actually used foundation blocks. You can use the 12-inch or you can use the 18-inch. You can use 2 stacked together, or you can use 1 as I did and put gravel underneath to level it out. Ideally a slab would be poured. In this situation we landed up using foundation blocks. But the gravel underneath leveled the land, and then we used the blocks on top. Now notice how the board is actually 3/4 inch plywood, constructs the box, and at the bottom is a small lip. I place that lip at the bottom and screw it on so that it sits on top of the cement form, or the foundation blocks as we've used in this case. On the ends, I recycled some old wood. You can use a 2x4 and actually formed the box that way using drywall screws or treated decking screws, and go ahead and assemble the box. So basically you have a long piece in the back. I'm using a shed construction here where the top, when it's down, drains the water off, and the front piece, which is shorter than the back piece. Now notice here we had to piece 2 pieces together because it was longer than 8 feet, 1 piece of plywood. If you have to do that, go ahead and piece it together. What we did was used plywood glue and screws to put a lapping piece over to join these 2 pieces together, and that works very well. And as well, we did it with the roof part here. Measure all this out on paper first so that you get your dimensions. The drop, the angle of the drop from front to back so it drains, is not very critical. It just has to have a drop, and you have to clear the batteries. So measure your batteries and make sure that the height easily clears your batteries, plus the terminal height here, so you have lots of space under here. You don't want to get anywhere near that. And that, of course, by the time you're at the back, you're not going to have any problem. It'll be way above the back cells for easy access for filling with water. Now, we're also putting the electronics in a separate compartment over here, and we're going to go ahead and form that up by just putting another 3/4 inch plywood piece right there to separate this. And we're using the same technique in the corners. These pieces, of course, are not squares. They come up so that it forms that angle. And I'm using traditional hinges on the back and just screwing those in. Now, Our electronics are going to be in this box because we don't want any electronics in the same box as the batteries. And what we're going to do here is I'm going to power ventilate this by bringing air from the back over here, and then into this compartment, cooling the electronics, and then out of this compartment through a hole over there into the battery compartment, thus positively pressuring the battery compartment. And then at the very end, I'll put a hole with a screen over it to keep bugs out and go ahead and vent the compartment down there. So that'll work very well for us. Now I'm going to show you what we did with the top of the box. Now the top of your box is necessarily going to be pretty heavy. It's 3/4 ply, that's what I suggest. Don't use masonite. And then what we did was, on the back of the hinges on the top here, we did a really simple thing. I added a little lift spring. We're going to add 4 of those. I just put in 2. And a little eyelet at the bottom. And that helps lift the top of the box up for the user. Just make it easier for you to lift the top of the box up. We're going to put 4 of those springs in when we're done. We have 2 right now. Now you'll see on the corners I've used this metal cornering here. It's just a finishing way to finish the corner. You don't really need to use that. For a couple of dollars you can go ahead and finish the corners of the box like that. When you're doing fresh construction like this, the idea was that we were able to completely fabricate the box and then put the batteries on our concrete pallet first and lift the box over and place it over the batteries. That way we didn't have to lift the batteries over the edge of the box to put them in. It's just a matter of making it a little bit easier for us because this is all being built from scratch. Now notice I put a ground rod in right next to the box over here. I'm going to run this nice thick copper wire right into the electronics compartment up here and attach it to our equipment. Now on back of our box, I've taken out the vent on the side of the house over here, and we're going to route our big wires into the house over here to go to the inverter. I'm putting the inverter outside of this box and underneath the house. That's one of the things I like to do. The very short run from the battery box. We're also going to do the trick of taking air from underneath the house through a dryer vent, and I'm going to show you how we do that, and routing it, sucking it into the box so that air is warmed in the winter and it's cooled in the summer. Sort of conditioned by the temperature of the house, and that will come into the back of our electronics cage on the left and be pressurized through the batteries to the right. If your battery box is not going to be outside and a little bit of liquid coming out of the batteries might drain underneath the box and cause a problem, say in a garage or something, you can line the bottom of the box with a little bit of vinyl. And I did so here using an old shower curtain. This is a small battery box, and in the end is the charge controller over here. You can see the screened vent holes here, which are nice. I just put a little bit of old window screening over there and used a little caulk around the edge to glue it in place. I also provided a little bit of a piece of wood here to brace the lid open.
Once you've measured your batteries and you know exactly how big of a space you're going to need for them, and then your equipment compartment where you're giving everything a little bit of extra elbow room, you can go ahead and write down the dimensions you're going to need for these pieces. The rear wall, the rear piece, the front piece, which is going to be shorter because you're having that shed roof tilt down. There's your lid and top on the top right. It's going to have about 4 or 5 inches of overhang in the back and right and sides for a little bit of rain protection. Then your 2 sides, which are going to be exactly the same, mirror images of each other, and then a slightly small divider wall that's the same shape, but it fits inside the box. Now on the bottom left, you're going to see you're going to cut some scrap pieces of wood that can be 2x2 or 2x4 to form the corners of the boxes, to insert on the wall and sides and use your screw gun and put screws and glue in there and form the box. So you can, of course, do this without these, but this will give a much stronger box instead of just screwing the box pieces together to ply together in the corners. Put that inset piece in and screw the sides and the front and the back into these 2x4 pieces. So your ones for the back are going to be a little bit taller because the rear wall is taller, and the ones in the front are a little bit shorter. And on the bottom right, out of 3/4 ply, the box material, you cut strips that are maybe 3 inches tall, and then the length of each of the pieces, the rear piece, the front piece, and the sides, and you're going to screw those in about 1 inch up from the bottom of the box. That will allow the box to sit onto the form and have an overlap onto the concrete, yet not go all the way down, maybe 1 inch or 1.5 inches of overlap, and hold the box in place above the pad itself.
What we've done is go ahead and take the fill dirt and level it as best we can by eye. Using a level, we check it, try to make approximately the base of the box in dirt, and then we can either put a form, in other words 2x6s in a square, and fill it with some cement about 4 inches thick to make our pad, or we can use blocks like this and stack them, foundation blocks or 1x1s, and you'll see how we're going to do this one with the 1 foot by 1 foot. But you can go with blocks, or you can backfill it with cement and do that by hand. What I've done is to level the pad using just a 2x4 and smacking it down and adding dirt until when we put a level on it, it's fairly level front to back and side to side. Now we've got the gravel poured out, this sort of 3/4 pea gravel, or you can use 1/4 inch. It's also called drainage rock when we're using the foundation pads or stepping stones of precast pieces instead of a poured base. We're going to go ahead and level that out. We level the dirt out as best we can, then using a level, a long one, or like we're using a 2x4 with a level on it, level out the gravel so that you have it as close to level as you can for the base of your pads, and then we're going to build the box on top of that. And we level our gravel using a level and a 2x4 with a level on top if you don't have a long one, and then go ahead and place your blocks if you're using the block technique, and use your eyeball to level them and get them as straight as possible, and then you can measure from the diagonals from that corner to this corner and the opposite to this corner to that corner with a tape measure, and be sure that you really have a square and move them around until you do. I left a channel in between to give us a little bit more distance from this to this here because I needed just a little more breather room in the box. You might butt them up together, maybe not. You cut out your box pieces. Remember the old rule, measure twice, cut once. I'm using a chalk line, red chalk line here, to mark the pieces of plywood and to cut them out. And here are the little strips which form the lip on the bottom of the sides of the box to sit it on top of the foundation. I used plywood. Now on this box it was over 8 feet wide, so we had to piece 2 pieces of plywood together. And you can see what I did here, just made a 6-inch strip of plywood and glued it with adhesive. We used a liquid nails type of adhesive and screwed it. So we pieced the 2 pieces together. And then we're going to put a lip on the bottom edge so that it holds the box above the foundation. These are little pieces of sort of 1x2, or you can use 1x2 or 2x4 material. We had some extra pieces from an old bed and glued and screwed them on the edges of the pieces of the box. These form the box and allow you to screw the sides to the fronts. So here are the side pieces, sort of a trapezoid in a way, and these little cutouts of material, which are from plywood, are little 3/4 by 2-inch strips that form the shelf, which makes the box sit on top of the form, of the cement form. Now on the front and back of the box, notice I seamed the 2 pieces together, but also I made another strip, that same extra plywood material, and put it exactly 1 inch for 1 inch of overlap over the foundation bricks or the concrete that you poured, so that the box can actually be sat right on top of the foundation. And so basically once we assemble the box, and we can assemble it on top of the pad, we can then pick it up, move it, put the batteries on, and then lift the box and put it back into place so we don't have to lift the batteries over the top of the box. Here's the front piece. It's a little shorter because the front of the box is lower than the back of the box, so that your roof tilts down like a traditional shed roof and it drains the rain off of it. We use scrap material. You can use a 2x4 like I said for the corners, glued and screwed, and there's our shelf material, that little strip that overlaps the foundation on the bottom and holds the box onto the foundation. Here's how the corners go together. There's a little piece that puts the 2 sides together, glued and screwed together, and there's our little strips at the bottom actually holding the sides up on the blocks or your cement pad. I actually put these sides together with just one person by putting little blocks and holding the sides up in position. Here's our pieces that laminate the 2 together, the 2 front and back side pieces and side pieces. And there we go. So now we'll fabricate the top. In this case, of course, our top had to be 2 pieces. It overlaps 4 inches on both sides. You see the lapping piece actually leaves 5 inches top and bottom for overlap and the thickness of the box itself. So this will be our top. We'll put hinges on it, and then we'll treat the top of it so that it's waterproof. You can see how our box is actually overlapping the pad. That gives a nice little drip edge down there, and it's sitting on this drain gravel. Gives us an extra measure of safety against any water that might build up on the ground. And here we're progressing along with the battery box. I put the separator in. You can see this little panel over here. What this is, it makes a separate compartment for the charge controller and the breaker box, because we want to power ventilate into this box from the outside or under the house, and then out of this compartment into the battery compartment. So we have a positive flow, airflow pressure through the battery compartment, first coming through the electronics compartment over here. And also this helps rigidify the box. You can move this around if you need to a little bit. We sort of roughed it in for right now. The lid has been put on with the hinges over here, somewhat equidistant across the back. And just about done putting our hinges in. And then we're going to do a counterweight system so that it helps you lift up this rather heavy lid. There we go, one day's work. A box construction hit point. When you're cutting the box pieces out, add an extra length to the front and back walls so as to overlap the sides. And the amount that you add in length is twice the thickness of the plywood used. So if you're using 3/4 plywood, just like Jess, go ahead and add 1.5 inches to both the front and back walls so that those overlap the sides. Now that we've got our box finished in its basic configuration and primed with a good primer, I'm going to use an exterior oil-based paint. Marine grade paints are really good, something that's really, really waterproof on the exterior. So give it a good primer, make sure it's clean, and then go ahead and coat it with the best paint you can get for exterior protection. And I'm going to match the base of the house in this case. White is good if you're going to get sun on it because it'll reflect that heat off of it, but also this fella happened to have some of the exterior grade paint that he used on these blocks over here, so that's going to be perfect for our box. It'll match in the color and it'll look good and protect it. And again, on the top of the box we have the option of using comp shingle, standard asphalt shingling, trying to match it to what the house has. If your box is not too large and the lid is not too heavy or large, the comp shingle is rather heavy, so you can use sheet aluminum on that, very thin sheet aluminum on that, or if it's in a place that's partially protected, which this is, you can use the exterior grade paint on it and give it several coats, and then every couple of years give it another coat and it should be just fine. Well, that was a big chapter, so let's review. Number 1, wire a set of your batteries in series to get your desired voltage. That's the battery bank voltage, 12, 24, or 48, and again I like 24 a lot. And number 2, clone that set and wire those sets in parallel to obtain the total amp hours you need in your battery bank. Remember, 20 to 25 times the continuous amp output of your array is what you're going to need in that battery configuration, depending on your location. Number 3, tape your tool handles, wear safety goggles, and no jewelry in the battery box. Be like a jet fighter pilot in there. Very slow, determined, clear, and take your time. Number 4, never short the plus and minus from a battery or set of batteries output together, because you'll have an explosion and you'll really want to avoid this, so take your time and go very slowly. Number 5, pre-measure your jumpers and construct the whole set of jumpers first. But don't do it all in a row. Do a few of them, go do something else, but have them ready to go when you're ready to do your whole battery bank. Number 6, design the battery box in a shed design with a draining roof, a simple rectangle with the roof tilting down so it drains the rain. Number 7, give ample room for all the equipment inside and your little separate compartment for your charge controller and inverter and such, and breakers, and then a separate compartment for your batteries, maybe a little bit of extra room for a couple of jugs of distilled water in there. Number 8, pour a concrete slab or use foundation blocks for the base of your box. And number 9, top the box with composition shingles. You can match them to the house. You can use sheet aluminum or tin or marine grade paint if the rain problem is not that bad or you're partially covered with the box. And number 10, battery jumper wire size is determined by the inverter size. If you're under 2,000 watts, you can go with 2 gauge or so, but over 2,000, you need to go with 00 or double-aught wire.